Awesome. So this is a very common topic, right? How do we define creativity and hallucination when it's like it's the two sides of the same coin? When it works for us, it is creative. When the same outcomes don't work, it's hallucination. So like the same models can generate like penguins driving the car. The same models can generate like handshake. So like how does this vary? What happens inside? It's the same interpolation in the latent space. It's the same model, same weight, but the outcomes are different. So something internal is changing between these things, and the way we perceive it defines the difference. As I said, when it works, models are creative. When it doesn't, they start hallucinating. And let me get reorganized here. So let's understand the journey that goes from when we type in, like, I want to generate an image to the image coming out. A lot of these were laid out by Professor Lalita before me, so that was very helpful. We start with taking a prompt, encode it, and that prompt is converted within the latent space through various ways, and then decoded through either diffusion, autoregressive, or hybrid, like the new nano bananas that we are seeing are a hybrid between autoregressive models and diffusion models. So what is essentially happening is your phrase is transformed into a vector, and that vector is predicting a sequence of tokens, either in the image space or in the text space, and that text tokens are getting converted. So that's the process, and like we have a decoder to convert that to images. So all good over here. What causes the issue? When recent research was looking into it, they found early steps are good. Like early steps are just taking your input, projecting it, and making the decoder or the diffusion model understand what your input is. As it's starting to decode, the later stages of the diffusion model tries to fill in details. Details like, is it going to have a little bit extra finger over here or stuff like that? It wants to be more creative. It's going away from the instruction that the input is giving and trying to go more adhere to the statistical significance that it was having through the training process. And in that phase, it starts screwing up. So it's starting to go away from the prompt. So that's where the problem happens. In the later stage, it forgets what it's been asked, and it starts doing what it knows. And what do we do? The first point, Professor Lalita addressed this on classifier-free guidance. In essence, in a word, what we are asking is, if I don't give you this prompt, what would you have generated? And with this prompt, what are you generating? Can you correct that gap so that like you don't freely think, just keep generating what the prompt is instructing you to do. So we are trying to bridge that gap, close it as much as we can through classifier-free guidance, or we can just keep putting 20,000 instructions in the prompt saying like, don't generate extra fingers, no blurry text. And like that list can keep going on and on and on after you see what the outcomes are. Or Nano Banana Pro, which is also a very interesting thing which they did, is reason before generating. It's kind of in the line of negative prompting. Like it's hard for us to guess what are the 20 things that we should say not to generate and what are the 20 right things we should say to generate. But Nano Banana, what they are doing is they are having intermediate steps that refine your input in certain ways. And they have this entire process fine-tuned for that, where like they're training the model itself into that process. Or there is another interesting line of work, contrastive decoding. Generate twice, generate one with it's very close to classifier-free guidance, where the first step we generate with a really good model. It's kind of like write the correct answer in the purview of a professor and the student and compare what is the gap over there. And the student's answer could have certain things that are not right, taking the professor's answer as oracle and removing things that should not be there in the oracle answer. So that's kind of like one with a smart expert, one with a dumb amateur model, and subtract the common error points from the expert model's outcome. And with this, we are able to reduce hallucinations. Like if we start doing this on a distribution level and fine-tuning the model itself, we are able to start reducing hallucination. But the catch is none of us can do any of that. Like it's all for people who have access to GPUs and stuff like that. We cannot train models, we cannot do classifier-free guidance, we cannot do contrastive decoding, we cannot fine-tune models and stuff. We can reason before generation, but that means it is too expensive for us. We need to like have a lot of GPU tokens and stuff, or we need to be able to control what the model's text model's predictive outcome is going to be. What an average everyday user need. Prompt in, image out, where we have access to few little elements that we can start using. Our biggest tool is controlling how the prompt goes in, what we can do about it. To understand what we can do with the prompt, let us take a step back. We started talking about latent spaces. Let us understand what latent space can do in essence. So latent space is it's the place where the models draw. I'll position it like this. We have an image distribution. We want neural networks to generate that distribution. We map the distribution to a known prior distribution. Many cases, it would be Gaussian priors and stuff like that. And between this mapping is where the neural network sits, where it can sample from the known distribution and generate a corresponding image. But there is a lot happening in the process of learning to map. So latent space is a semantic map of what the image distribution model, image distribution itself is. And very interestingly, that space is traversable, which is what gave rise to edit your images, change it to smile, make you stand in front of Taj Mahal or whatever. Like all these edits can happen within that latent space. But we started asking few questions, like few of these work were also with Pawan's group, where we asked, what is the extent in which we can push that latent space? Can the latent space generate images and like invert images that the training has never exposed it to? For example, if we have trained the image generative model with only human faces, can we invert and generate chest X-rays? Can we generate like retinal images or dog images? We found we can absolutely invert, find an isolated point, and regenerate, which means these points exist within the latent distribution. So a face-only trained image generator can invert and generate chest X-rays and dogs. So OOD is no more just not outside the latent space. We want to redefine it as the points that are yet unexplored within that latent space. Then we pushed in asking, instead of isolated points, can we learn a distribution of OOD images within that latent space? And the answer was yes. Not only can we invert isolated images, we can find a distribution of out-of-distribution images within the latent space. What we did after, so how do we use this to solve our problem? The goal is, how do we control the images that are being generated for us so that it is useful? So I want to introduce one more tool, vision language model. They are essentially concepts that bridge images and text into a latent distribution. So all they are doing is taking a huge distribution of images with corresponding captioned text, and they're figuring out a latent distribution where both of them can coexist close to each other. So the image of a cat with skis in that distribution will live very close to the text point embedding of cat with ski goggles. So what does this give us? It gives a space where images and text can coexist. How do we leverage this? Now let's connect the picture. We want to create better prompts. We want to use these vision language models as evaluators, where you generated an image, the image sucks. We want better way to control what the input prompt is. These VLMs are hosted online. It gives us, given an image, it can go to the embedding space, and it can tell us what the image is containing, literally as a prompt description. We take that prompt description, we keep mutating that description, till we get better images. So we are essentially saying, generate an image, I'll have another system look at that image and compare that image to the original request. So we asked image with a cat with ski goggles, but what came out was prescription goggles, let's say. The VLM will say, this is an image with the cat with prescription goggles. Now we know where the discrepancy is. We take that discrepancy, go to another LLM and say, are these two sentences the same? Can you correct that error? We again correct that error, go back to image generator, keep regenerating this, keep regenerating the image till it is very close, and VLM says there is no discrepancy between what is generated and what is being asked. So with this, we are able to generate images with very great accuracies, with text inlaid in it, more scientific diagrams and stuff. But we then asked, is this only limited to generating images? We pushed the fold, and we started seeing, with the same process, we can generate an entire suite of visualizations, code, and everything, where with an input prompt, by iteratively refining it and generating, we can generate these kind of visualization concepts, where users can go in, interact. This one is like an interaction that explains what SVM decision boundary looks like. And this one is an interaction that was created to show mass spring collision oscilloscope. And we kept extending this and seeing what more can this do. We are able to generate timelines, graphs, plots, just by this iterative evolutionary prompting. It is pushing the manifold. We are still discovering new things that we're able to do. So that concludes. I want to say, like, hallucination and creativity is just two sides of the same coin. Everything rests on what we ask it. We need to point it to the right direction. We need to find the right inputs that can bring out the right outcomes from these models. So that's it.